So how many of you are familiar with the graph? Just curious. All right, quite a few. How many have built something with the graph? Okay. Well, I guess like most people here are not developers, okay? So I'll try to do this like, as less technical as possible. So essentially the graph is a protocol, a decentralized protocol that allows you to access like blockchain data, right? Essentially, let's like break down that sentence in two, okay? Accessing blockchain data means essentially we have like indexers that are responsible for scanning the blockchain, almost like every moment. Decentralized means that these indexers are like permissionless, are distributed across the globe, and they provide redundancy in case of someone going down, right? So you always have accessibility to your data in the decentralized network. A few facts, important facts about the graph is that like we have like hundreds of indexers worldwide. We are supporting more than 70 chains. We have recently integrated Injective as well, while we are here, to create awareness that you can right now index Injective data in the decentralized network. We have our token GRT, which is a utility token that is used across the network, to pay indexers and for users to pay for query fees. And something that we want to mention is that this is super reliable. There are a lot of, especially EVM protocols that are using the graph in production, and it's quite affordable if you compare it to centralized services, right? We have two main products. The first one is subgraphs. If you're familiar with the graph, probably you know subgraphs, because especially in the EVM world, they are pretty much standard. Essentially, subgraphs allow you to select which specific data you want to extract from the network and making that data accessible through a GraphQL API. And we have substreams, which allows you also to select which specific data you want to extract from the network, but you can do it through a streaming fashion, in a streaming fashion way. Okay, I'll talk about both in a moment, but just for you to have a big picture of it. Okay, so essentially what we are trying to solve here is a problem of reading, right? The blockchain is write optimized, but the reading issue means like, okay, how do we provide our front ends with the information that we want, right? Some huge protocols might need like the full block of the blockchain. Some other ones might need some small pieces of information that they want to show in their dApps. So the thing is like how we do integrate this with our front ends in an easy, reliable, and affordable way, right? So that's essentially what the graph is trying to solve. The first product I'm going to talk about is substreams, okay? So let's say specifically for Injective, you want to like extract a specific type of event, right? And you want to show this in your tab, right? Substreams is essentially going to provide you with an infinite stream of data, both historical and real-time data, okay? That can be filtered by type event, by attributes, by anything that really covers the Injective data model, okay? So it's really up to you how you select which specific data from the Injective data model you want to extract in your dApp. And the good part about substreams is that it does not impose any consumption on the consumer side, right? We have the Injective data, we have substreams, which is a bridge between the Injective data and other places. It could be a front end, it could be a SQL database, it could be a subgraph that I'm going to cover in a minute. But essentially, substreams is a streaming solution. Does not impose anything on the consumer side. You're free to consume this data as you like. We have specifically libraries for JavaScript, for Python, for Go, and for Rust. So we pretty much like cover a lot of languages used in the Web3 space. We have also a sink specifically for SQL. So if you want to just taking all this stream and dump it into a database, so you can do like SQL queries on top of it. That's also possible. And if you're familiar with subgraphs, because you've worked with the graph in EVMs, well, it's also possible for substreams to breach that data into a subgraph, right? And for you to get a GraphQL API. And if there are like front-end developers here, I'm pretty sure like you'll be interested, because like integrating a GraphQL API into a front-end is like super easy. Okay. Let's go. Okay. Now, this sounds like difficult, but the thing is like we have created like several auto-generation tools for you, all right? So you can bootstrap your project right away. Obviously, the graph, supports a lot of blockchains. Injective is one of them, but you also have Solana, you have EVMs, you have Starnet, you have Mantra, which is also, a Cosmos-based blockchain. We have Bara. And essentially, this is the CLI that we are providing, okay? You can install this in your computer. You can go to our documentation. You can install it. You can run substreams in it. And you will be prompted with all these auto-generation tools for different blockchains, right? So in the case that we are selecting injective events here, that means we are going to get injective events filtered by type, attribute, or whichever way you want, right? If you don't want events, you want like the full block from Injective, you can select Injective Minimal, which is up there, and that will give you access, to the full Injective block. And from there, you can select in Rust, which specific parts of the data model you want to extract, right? So as I said before, like it's totally customizable, and we don't impose any restrictions on what kind of data you want to extract. Now, the only reason why we've built injective events is because like most developers just want events, right? So we want to facilitate these developers to create or to bootstrap a substreams project. Okay, the second thing I want to cover here is like substreams power subgraphs. So this is essentially a normal subgraph. If you know it from EVMs, that is powered by the substreams technology, right? So essentially, the substreams is going to get like information from Injective, is going to filter it, and is going to pass all this information into a subgraph. This subgraph can be deployed in the decentralized network, right? So once this subgraph is deployed in the decentralized network, a bunch of indexers will start like listening for injective data, and will like make it accessible through a GraphQL API, right? This GraphQL API is like easily integrable into a frontend. And that's why a lot of front-end developers have been using the graph for a long time. Yeah, let's. Okay. Okay. Once you deploy your subgraph to the decentralized network, you can see it here in the Explorer, right? You can see that you can query it. And so to make these queries, you essentially use the GRT token, right? You can also pay with credit card, with whatever, but usually use this GRT token, which is here. Now, something I want to mention, like the first 100K queries on the network are totally for free, so you don't have to pay anything, right? And of course, you see here that different indexers are indexing like the subgraphs, right? This is like, as I mentioned before, a bunch of indexers, different indexers from around the world are providing redundancy in the graph network to all these subgraphs. And yeah, well, you can see it like pretty well here. Should be in white. But essentially, like we are comparing here subgraphs and substreams. I'm going to go super quick through it. Essentially, in subgraphs, you have a request and response model. So it's like a standard polling method of accessing an API. And you have managed infrastructure. This is super important also because we have like different options for different use cases, right? It's not like we are competing subgraphs and substreams. They serve like different use cases. In the case of subgraphs, that information that you extract from the blockchain is totally managed for you, right? So there will be an indexer that will host that data for you, and you can simply like query that data from the outside. Okay. For substreams, you have to take yeah. No. No. Okay. Now better. For substreams, instead of the request response model, we have the streaming model, right? This is super interesting, like for real-time applications, in the case that you need it. But it's also good for historical backfilling, right? It's super fast. We have like very good indexing times. Okay, so if you want performance and you don't care if you have to store the data yourself, I would definitely recommend Substreams or give it a try to Substreams. Again, if you want to, if you want something hosted for you, just go with Substreams Power Subgraphs. And yeah, essentially you can access the data in a variety of ways, right? Whereas in where in subgraphs, it's essentially you are imposed this GraphQL API interface, right? So yeah, essentially this is like a quick overview of the graph, of the different products that we have in the graph, specifically for Injective. I could do like a demo for anyone who's interested here. If you're a developer and you want to get started, consuming Injective data, I can do a demo for you after this meeting. And if not, like you can find our documentation, very complete getting started guides that you can follow and you can use to get your Injective data, right? So if there are any questions. Oh, okay. Thank you so much.